What's up, everybody? Today is March 4th, 2025, and I plan on actually doing two of the dailies today because I didn't show yesterday's daily, but I'm going to go ahead and do that one now. I have done this problem before, so it's really not as bad. Um, for this problem, there's several ways to approach it, but I'm just going to do a sort of greedy approach, and I can explain what I'm going to do. Basically, I'm going to generate the powers of 3, shove them into a vector, and then in reverse order, once n is greater than the power that I'm using, I'll just subtract it until I get to the end. And if it's not 0, guess what? It didn't go into it. So it's pretty much the greedy approach. So let's go ahead and, generate. We're going to do, huh? Oh, man, I forgot. I don't know. While weight is less than 1e7 plus 1. And I'm getting this number from the constraint here. And we're just going to go if n, oh, no. We're generating first. We're going to say back dot push back the weight, and then weight times equals 3, right? So go 1, then 3, then 9. It's the powers of 3. Then we'll go ahead and go in reverse order from the vector. Right? And then we're just going to say if n is greater than or equal to vec I, then we just want to subtract the value from the vector. Okay? And then we just want to say if n is equal to 0 or not n, we can return true. Let's return false. Right? I'm pretty sure this is about correct. So like I said, I generated all the powers of 3 here. I go in reverse order and greedily subtract when n is now greater than the power that I'm looking at. And then if it's evenly subtractable because they're distinct, then it should be 0 if returned true. Let me go ahead and submit. Yeah, and that's the solution to the first one. Okay, so I just wanted to do that one, just to get it out there because I didn't do it for you guys yesterday. What is this? Oh, debugger. Let's go ahead and do a type racer first, or in between. Okay. Now this is the actual daily today. So this is 2579. Oh, I never read the description of the first one, did I? Basically, we're looking for distinct values. I know I'm doing this in a backwards order. We were looking for a distinct sum of powers of 3 to add up to n. Anyway, that was yesterday's problem. That's basically how I solved it. If you have any questions about my approach or Any comments about it? Just let me know in the comments. Okay, this is the one for today. I haven't actually seen this one yet, so 2579, count total number of colored cells. There exists an infinitely large two-dimensional grid of uncolored unit cells. You are given a positive integer n, indicating that you must do the following routine for n minutes. Okay, at the first minute, color any arbitrary unit cell blue. Every minute thereafter, color blue every uncolored cell that touches a blue cell. Below is a pictorial representation of the state of the grid after minus 1, 2, and 3. So we have the 1, then you go out and you have 4 more. Then you go out and you have 4 and 4. Which is 8. I feel like you could just do a loop. Like, okay, this is what I'm thinking. So if it's 1, and then it spreads out to 4, right? So you have now the 4 new ones. So it's 1 plus 4 is 5 for the second one. Okay, and this is a running wait, so then you would add four more, right? So it would be 1, 4, 12 cells? Or you would add 8? Or no, yeah. You'd add 8. Because it's 1 plus 9 plus 4. 13. Or no, I'm sorry, 9 plus 4. Yeah. Which means if it followed this pattern, if you expend one out more, it would be, you'd add 12. Right? So the level would then become bad. Right? So 1 is 1. So say if I add a test case, and this test case is level of 4, then it should be this sum. So this should be 25, right? So this is 13 plus 12 is 25. Yeah. So you're just... Level 1 is 1. Then you add 4s. Yeah, then you just add 4 to the weight every time, right? So we just go if n equals 1, return 1. Give me 1 for, yeah. Okay. Whoops. 8.8 equals 4. 0, I less than n, I plus plus. I think this is n times... Wait. So we have 4 times a certain number of things. I don't even think we need a loop. Hold on. So if it's level 2, then we need 1, 4. Uh-huh. If it's level of n minus 1. Okay, so n minus 1. But it's the sum of the values up to that point. Okay, so what if we divide them by 4? The sum, right? So it's like 4, it would be 1 plus 2 plus whatever the sum is, right? So it is n times the sum of natural values for n. Ooh, that is such a sick answer. If I do it this way. I wonder if that works. Which means I wouldn't even necessarily need weight, right? So so the sum of natural numbers is n times n plus 1 divided by 2, right? Okay. And then this is going to be multiplied by 4. So we have this. Okay. We could get rid of the 4 times, it's a 1/2. So we could say 2 times n plus 1, right? Would that work? Let's see. N 1, 2, 3. This is actually n minus 1. Which makes this 2 times n times n minus 1. I wonder if my math is going to be right. Let's see. 2. Okay, so if we're at level 2, we'd actually be at level 1. Okay, so this is level 2. One times 0. Make the 0. Oh, wait, no. Well, then this is plus 1. My bad. Okay, is it just a... Is this it? Is this the whole formula? Let's see. Sign integer overflow. Oh. Yeah, I have to convert this to long. You can just do that, right? I can't remember if you can convert... Hold on. Okay. So this should convert it, because I'm using these, yeah. Okay. Alright, there we go. Wow, that was a lot easier than I was gonna think it was gonna be. Okay, well, sweet. Thank you for joining in, everybody. This actually ended up as a much shorter video than I anticipated for me having two problems. Thank you for watching. Have a wonderful evening. I'll see you next time. Peace.